Alright, let's go and discuss about angles of elevation and depression. Before we go to angles of elevation and depression, let's have a look first on an application of trigonometric ratio. This is these things you can only solve this whenever you already mastered SOHCAHTOA. Alright, so I have also made a video regarding SOHCAHTOA. You may want to check it if you still struggle with that. So I think you need to look back to that. So we have here SOHCAHTOA. Alright, so O means opposite, H is hypotenuse, and then A is adjacent. Okay, so SOHCAHTOA. So here we are given with a housing block is 47 meters. So this should be A here. And then 47 meters by 19 meters. First thing is we need to find theta correct to 4 significant figures. So this is how we do it. We need to apply what formula should we use from SOHCAHTOA. You have to check your given. This is a rectangle, but we only need ACD, triangle ACD, to compute for the unknown angle, which is theta. First things first, we need to label our given data or our given triangle. You have to label it. From the theta, you would know that this is our opposite, and this is our hypotenuse, and the remaining one is our adjacent. Alright, so to solve for theta, letter A, okay, to solve for theta, we need to be looking at what are the sides that are labeled. Okay, the sides that are labeled are O and A. Therefore, we're going to use the formula TOA. Okay, because it has O and A, or opposite and adjacent. So to find the measure of our theta, we will be using tangent theta is equal to opposite over adjacent. Then we have tangent. So we don't know the angle, the measure of our theta. Our opposite is 19, and we have our adjacent as 47 meters. Okay, so therefore we need the tangent to be written here. We need it to be written there. So theta is equal to tangent raised to -1 and then 19 over 47. So if you feel the need that you don't understand some of this part, I suggest you look back at the video about finding angle measures using trigonometry, because that one has a detailed discussion on this one. We are going to use a Desmos calculator to find the exact measure of our value here. So it has tangent raised to -1. So you have to go to function tangent raised to -1, and then your fraction, and then what value? 19 over 47. So you have 19 over 47. So because there's so many things going on right now, Desmos is good for those students who forgot their calculator, or those who can't purchase right now. Okay, so because of being indoors. So we have here the value 22.01. All right, so we have to write that down. So we have theta, therefore, is equal to 22.01. Okay, so that actually it's not equal to, it's approximately equal to. Okay, let me write that down again. So it's approximately equal to 22.01 degrees. Don't forget, when it's theta, it's degrees, or you could just write 22 degrees. So by that, we already know the theta. Therefore, we know the theta to be 22 degrees. Now, the next step is to solve for letter B. It says the length of AC. We want to find AC using trigonometry. So when you want to find AC using trigonometry, remember it's H. So you have to pick from the formula SOHCAHTOA which one has H. You can either pick SO or Ka. Okay, so we will be picking SO. So to answer letter B, SO is sine theta. Sine theta is equal to opposite over hypotenuse. So we have sine, and then we have the value for theta, which is 22 degrees. And then what's our opposite? That's 19. And we don't know the h. Cross multiply. So sine theta, sine 22 degrees will switch with our h. So h will now be on the left side. And then we have 19 over sine 22 degrees. Okay. So let's go and check our calculator. So what's the value of 19 and then over 19 over sine 22? Sine 22. So we have 50.72. Okay. 19 and then sine 22. So we have h is therefore equal to, or not equal, it's approximately equal to 50.72. And don't forget the unit, it's meters. Okay, let's now use our Pythagorean theorem. So the Pythagorean theorem says the sum of the square of the two legs, so that's a squared plus b squared, is equal to the square of your hypotenuse. Alright, let's check. We already have here from the given the measures of our two sides or two legs. Okay, so this is a and this is b. So a is 19. You can write 19 squared. Alright, 19 squared plus 47 squared equals to c squared. So you have 19 squared is actually equal to, okay, 19 times 19 would make 361 plus, what is your 47 squared? This is 47 times 47. This is 2,209. Right, equals to c squared, and then add them up, 2,209 plus your 361, which is 2,570, equals to c squared. And then we want to eliminate the exponent here, so this will be, take the root. Okay, take the root to remove the actually, if you want to remove the square or the exponent, you could take the root of a number. Okay, take the root of that, and then that will cancel out. So this will be, what is the square root of 2,000? Square root of 2,570. Okay, so let's show it here. So square root of 2,570 is 50.70. So therefore c is equal to 50.70 meters. As you can see, this is approximately also. As you can see, if we try to round this off as a whole number, this will give us both 51 meters. Okay? So that is our answer for the application. Let's now go to our angles of elevation and depression. Alright, so we have here angles of elevation and depression. Say for example, you went on a camping, alright, and then you decided to go on the summit, at the summit of a certain mountain. Okay, at the summit of the certain mountain, you look out, you can see a helicopter. Okay, in the distance, high overhead. Okay, actually the human should be down here, but I just draw that way so that it's visible. And then the angle between the horizontal line, so this is an imaginary line. The broken line is the imaginary line or the horizontal line. And your line of sight of the helicopter is your, so let's just say this is your line of sight, okay, is your angle of elevation. So let's write that down. So this angle right here, this is actually the angle of elevation. Okay, angle of elevation. Alright, so this is the angle of elevation. And then the angle between the horizontal and your line of sight, yeah, that's the elevation. And then the angle between the horizontal and your line of sight to the tent is called the angle of depression. Okay, so down here, if this is angle of elevation, the other one, this is our angle of depression. Okay. All right. Also, if we want to check what will be the value here, this one, this angle here, there's actually a topic in math. We call it lines cut by a transversal. So this, for example, this two lines, and then this parallel line, and then if you have a line cutting that, we call it a transversal. Opposite interior angles. These opposite interior angles are actually opposite interior angles are actually equal. They are equal in measure. So for example here, if this is our angle of depression right here, okay, this from the site of your tent going to the summit, this is called angle of elevation, right? But you know what? This angle of depression and this angle of elevation, they are actually equal. Okay? These two are equal. So sometimes if you are being given with the angle of depression, you can actually claim this one also, same as the value of depression. Because look, from our given here, okay, again, when we have a topic in math, we call it parallel lines cut by a transversal. The interior angles, opposite interior angles are actually equal. So this angle of depression is equal to this angle. Alright, so I hope angle of elevation and depression is now clear. So if this is your line of sight, you look up and there's a horizontal line cutting this part. This is called the angle of elevation, this part. Looking down to your tent, this is the angle of depression with the reference to your horizontal line. Again, this angle of elevation from our tent is equal to our angle of depression from our line of sight from the top of the mountain. Okay, let's continue. Let's have an example. Say for example, there is a bell tower. The bell in a tower is 64 meters above the ground. So let's write that down. So there is this bell, okay, the bell from the tower to the ground, okay, it is 64 meters. Okay, it's 64 meters. And then, okay, I'll just move this so that I can be able to solve this properly. And then it says here, the angle of depression from the tower to a car. So there is a line, right? So for example, this is your line of sight, and then you have a line here. Let's draw a line, okay, to your car. Then there's a line. Remember, it says here the angle of depression. So let's look back. The angle of depression is going down, and there's a horizontal line cutting it. So there's a horizontal line cutting it, and this is our angle of depression. Okay, the angle of depression. Because if you draw a line going up, that's angle of elevation, but going down is angle of depression. It says it's 11 degrees. Okay, and now you are asked how far horizontally is the car from the tower. So the distance here, we don't know this distance. Okay, the distance here, okay, we don't know this. This is the unknown value. Now the question is, how do we find this unknown value right here? If this is 11 degrees, right, we also know from the explanation I made earlier, the angle of depression here is actually equal to this part. Okay, see that? It's similar here, and this is also equal. So you will write here, this is also 11 degrees. Okay, and then look, what can you form? You can actually form a right angle. Okay, this is 64 meters at the side and this is 11 meters. Now the question is, what formula should we use? Is it the saw, ka, or the towa? So this is the thing you have to check. Label your triangle. This is H, opposite. This is our opposite. And then this is our adjacent. Look, this is the unknown, right? So you have OA. You need to find you're going to use a formula that has OA, and that's tangent theta. So therefore, we have tangent theta is equal to TOA, opposite over adjacent. We know the value for the theta. That is 11 degrees. And then your opposite is 64. And then your adjacent, you don't know. This is the unknown. And then cross multiplication, switch with your x. So therefore, 64 over tangent 11 degrees. Okay, let's find the value of that using the Desmos calculator. So we have here 64 divided by tangent 11 degrees. So we have 329.25. Okay, so we have x is 329.25, and that's meters. All right, or we need, actually this should be approximately equal to, or we need to make that into a whole number. Therefore, it is 329 meters. So you could make your statement. You would say the distance, therefore the distance here, a distance, okay, this is the one that you want to find. The distance of your tower to the car is 329 meters. Alright, that's all for today. Make sure to like and subscribe if you like the video. Thank you.